Hey guys, Trey here. Wanted to do a sort of quick video today about the severe weather threat coming up for the southeast. The SPC has now highlighted this enhanced risk, sort of 30% area for eastern Louisiana, most of Mississippi, into the western half of Alabama. Um, Looks to be a pretty potent, pretty typical early season sort of event. This is kind of the heart of the southeast severe weather season, March and April. So wanted to kind of look at the models, look at the data, kind of compare models and see what we're seeing as far as whether or not this is going to be, potentially a more of a severe wind threat with a squall line sort of configuration, or can we eke out some discrete tornadic supercells out of this, and this will be more of a tornado outbreak than a sort of damaging wind threat come Wednesday. So this is the current day 4 outlook for Wednesday. Let's take a look at what's happening currently, though. Here is the satellite image from today, and if you are a fan of amazing satellite imagery, this is just quite the view to behold. This is our current storm system that's affecting the southern plains. Affected yesterday, we had a moderate risk in the Texas Panhandle. There were multiple tornadoes out there. But just look at this beautiful system. Now, what's unique about this system is usually we would have a cold front associated with this. It would sweep all the moisture out into the Gulf, and we'd be completely dry here. But in fact, this system is not going to do that. We're going to get actually the opposite effect, where this system is actually going to pull moisture and continue that southerly fetch of moisture off the Gulf, and it's going to leave it right in place in the southeast for this Wednesday event. So that is a good sign that we're going to have good, probably high quality moisture advecting onshore with this system, and it's going to remain in place through Wednesday. You can start to see a little bit of southwesterly flow out there off the coast of California. That is our next system. If we can get the bigger picture here, you can kind of see that sort of southwesterly flow. Our system is out here over the Pacific right now, sort of formulating at the moment. So that is going to come on shore toward the middle part of the week, and that's going to be our weather maker as this current system moves out. Let's take a look at our current surface chart here. We can see that southerly fetch continuing across East Texas into Louisiana, Mississippi, and Alabama. We've got 60s dew points from basically Shreveport southward down to the Houston-Galveston area. And all along the coast, we've got nice mid-60s dew points, and we see some 70s lurking right off the coast. So as this current system moves out to the east, those are going to continue to be pulled northward, and we're going to have a nice moisture plume in place for this event on Wednesday. So let's dive into the models a little bit. I'm going to try to make this video a little bit shorter than normal since we're still 4 days out, and this is basically purely kind of a model forecast at this point, kind of conjecture at this point. But here's the NAM, here's the 18Z NAM. We see our current mid-level low here at 500 millibars. That's going to move off, and we can see there that we've got our second system that is going to be the weather maker for Wednesday moving into California by Monday morning. That dives southward through the southern plains. There might be a severe threat overnight on Tuesday night into Wednesday, early Wednesday morning here in Oklahoma and Texas. Likely some elevated storms there as part of a warm advection regime. Kind of the sort of pre-event to our main event that's going to be on Wednesday afternoon. And we see that trough ejecting. We've kind of got two sort of main jet maxes here. We got this piece of energy over Louisiana and Mississippi here, and Alabama. And then we have our trough, our sort of upper low situated over the Oklahoma-Kansas border with our main jet streak here back toward Arkansas, eastern Oklahoma, into southwest Missouri. So kind of an interesting setup here, and I've talked about before that a lot of times for these big time Dixie Alley tornado outbreaks, I've tended to see that the 500 millibar flow is more out of the west or southwest than it is meridional. So for those of you who aren't familiar with that term, meridional means more north-south, while zonal means east-west. And in a lot of outbreaks, tornado outbreaks, where you have discrete supercells, not tornadoes embedded in a squall line, but discrete supercells producing tornadoes, you often see this more westerly, more zonal flow at 500 millibars. And that does appear to be the case here on this run of the NAM. At least before that main jet streak moves in, you kind of get a little bit more meridional flow there with that main jet streak. But this piece of energy here, nice southwesterly flow associated with that kind of split in the jet streak there. So that is a plus for this run of the NAM. And let's see how our moisture quality is here. We'll go ahead and zoom in to our southeast sector here. You can see that moisture already in place like we saw on our surface map. And you can see it doesn't really go anywhere. It doesn't get swept into the Gulf as our current system moves out. And then you get that just major warm advection, that moist flow off the Gulf starting throughout the day on Tuesday going into Wednesday, and actually goes pretty far up into the southern plains. Let me zoom out here. Get our southern plains sector. You can see it goes all the way up into southeast Kansas, kind of our warm front there. It gets a little bit pinched there as the surface low moves off, and you get moisture kind of pooling there. But actually very broad warm sector here across the southeast, and that's often what you see with big time Dixie days, is just a broad warm sector. Right, you're initiating boundary out there to the west, but a broad warm sector with very warm moist air at the surface, and that's what we're seeing. Lots of warm air advection going as that second system moves in. Here's our surface pattern. Assuming after we get that second system, that second upper low, to continue off to the east, we'll get surface cyclogenesis at some point, and we do. We can see the surface low. Whoops, we can see the surface low. It's centered up here somewhere in Missouri there, but pretty significant surface low there. Southerly flow off the Gulf there throughout the day on Wednesday. Winds at the surface are a little bit veered, but that doesn't seem to matter in Dixie so much. You often will get this little bit veered surface flow, but as long as you have large looping hodographs and your winds veer quickly with height toward the southwest, usually the little bit of veering doesn't really matter that much. So what we've got here is our surface low. This looks like what could be sort of a prefrontal trough. Can't really tell if that's the actual cold front. It doesn't look like it just based on the temperatures. There is a little bit of a wind shift there. Let me go to the southern plains sector and see. Yeah, it looks pretty interesting there. It looks like that's some sort of either prefrontal trough or that is the front itself. Given the temperatures, it doesn't really look like a cold front. Maybe more of what they call sort of your Pacific front there. So that is interesting as well. We also have some semblance of what looks to be a prefrontal trough for sure out here across eastern Arkansas into northern Mississippi down into Alabama. You can see the kinks in the flow there. That could be a focus in the warm sector for prefrontal storm development there as well. And when you have this sort of warm sector that's very large, and you have an ample low-level jet, pretty strong low-level jet acting upon it, you often can get pretty bad things to happen. And we see a very broad swath, of enhanced winds here at 850. That is your low-level jet, very strong low-level jet here, upwards of 40 to 45 knots here across most of the southeast. It's actually a little bit stronger here early in the day, at least on this model run, in the Mississippi Delta region, but stays strong throughout the region across the day. So just right off the bat, you can see broad warm sector, very warm, moist air at the surface with low-level jet. Usually that means bad things are going to happen, and severe weather is a definite potential here. So let's take a look at some soundings here from the warm sector. We'll do at 21Z. This looks like kind of a Pacific front, sort of this kind of dry line feature where you have much drier air to the west, more moist air to the east. Looks like sort of a Pacific front sort of configuration. You can call it a dry line, pseudo dry line, Pacific front kind of deal. Let's take a few soundings here. We'll go start up there in Arkansas, kind of closer to that Pacific front slash dry line. We see ample instability in place. Photographs are not quite as impressive as I would have thought. A little bit farther south here in northern Louisiana, unstable environment. A little bit more looping of the photographs. Not quite a lot though. I would expect to see a little bit more. And the farther south you go, it looks like a little bit more wonky. And one question I always have with these Dixie setups is, do we have an elevated mix layer in place? Usually the big tornado outbreak days in Dixie where you have discrete supercells, you have an elevated mix layer in the morning that holds off convection, inhibits convection in the warm sector, so you don't just get everything to go up at once and the mode becomes messy instantly. Usually you have a little bit of a cap in place, warmer air loft, to suppress development early on. And let's see if we have that. Let's take some soundings. This is at 15Z. We'll just take some kind of point soundings, and this is concerning. This is at 15Z. We clicked kind of right in there out in the open warm sector. You can see we don't have any cap remaining. There is zero inhibition remaining, even at 15Z. Let's take it farther down here in Louisiana. And we'll take one out here in Mississippi just for giggles. A little bit more of maybe a cap that might suppress things early on. Yeah, there's definitely some capping as you go farther south into the warm sector, at least on this NAM run. So that's going to be a question and something to watch throughout the next few days, is whether or not we have capping that will suppress storm development in the warm sector. By 21Z, definitely doesn't look like there's much of a cap remaining across the warm sector. We'll take some soundings a little bit farther east in the open warm sector, kind of along that prefrontal trough. And by this time, this is actually a fairly favorable sounding and wind profile for severe storms. Pretty decent instability there. Definite looping in the photographs. There is a little bit of a kink here in the photograph. A little bit of backing there at about 700 millibars of the winds. That'll be something to watch as well. I think if, as in most cases with veer back veer, if we can achieve a discrete mode for sure, this doesn't really matter too much. Although we'll see if this gets worked out at all over the coming days. So definitely on this NAM run, seeing some signs that this could be definitely a severe weather event to watch for. And this would indicate tornadoes potentially. You can see by 0Z, the kink kind of works itself out. Still ample instability, looping photographs, definitely favorable for tornadoes. But that'll be something to watch over the coming days, whether or not these kind of wonky wind profiles on the NAM work themselves out, whether or not we have an EML in place to suppress storms in the warm sector. All right, let's look at the GFS, kind of compare models here. So pretty much the same, nothing too different. Interesting to note here, this kind of first initial piece of energy arrives in the region pretty early. Just looking at this, we should have a primed warm sector already in place across the southeast as that sort of piece of energy arrives in the region by Wednesday morning, and that is the case. So that is a little bit concerning as far as early storms going up go. We want this warm sector to be as untapped as possible for later on in the afternoon. And we can see on this model as well, the GFS does not have the warm front nearly as far north as the NAM did. It brings it up throughout the day up into northeast Arkansas, but it stays much farther south than the NAM moisture profile, that warm front on the NAM was. But we can see very broad warm sector there as well, and we'll see, go ahead and take a look at the low-level jet here. and much of the same. Potent low-level jet across the entire region throughout the day, 40 to 50 knots here across Mississippi and Alabama. So that's pretty much the same. Let's see what the, let's pull some soundings here from the GFS. And to make this more clear, wherever this warm front sets up is going to modulate the northern extent of the severe threat. Storms north of the front will be elevated, so anything to the south of that warm front is going to have the potential to produce severe weather. Anything north, not so much. So where that warm front sets up is going to be important. Let's take some early day soundings in the warm sector, see if we see an EML. And we'll take a look at some soundings in a second to see if we can use some meteorology and guess whether or not we're going to get an EML to advect into the region. GFS not showing a whole lot of a cap in place Wednesday morning. So I'm a little concerned with that piece of energy arriving with a primed warm sector, very little cap. We do see some semblance of it here that might be something to look out for there, a positive at least on the GFS here. We may have a cap in place. Let's go to 21Z. We'll go along the front here in a couple areas, and then we'll go open warm sector in a couple places. So along the front, veered winds at the surface. These are quite veered at the surface, which makes for a pretty straight hodograph here. So that is interesting that the winds are very much veered at the surface. And then out in the warm sector, a little bit more turning there of the winds with height. Enough instability, more than enough instability there. If we look at the surface pattern here, that's interesting that the winds are so veered on the GFS. I would expect with the surface low in this position that the winds would not be so veered. That's pretty interesting to me. That they would be that veered in the warm sector. I would expect them to be a little bit more southerly, in turn enhancing low-level hodograph curvature. But we see our sort of, you could call it that Pacific front / sort of, prefrontal trough or whatever that is, pseudo dryline thing there. As you can see the kinks in the isobars there. And also we have that same sort of kink there, denoting kind of where the warm front is, and maybe a little bit of a kink out there as well. So there we do see some potential focal points for severe storms and storm development ahead of that Pacific front out in the open warm sector, which is where we'd see our discrete supercells, be most likely to see discrete supercells. So that we'll have to watch that. GFS very veered with the winds there out in the warm sector. I don't know if I buy that completely. I would expect them to be a little bit more backed out there, but let's look at the 12Z Euro here. I'm sure this upper pattern going to be much of the same here. We'll see, go Southeast US. Actually, whoops, let's go zoom back out to get the 500s. So here's our 500 millibar pattern, and we get that trough in there. Now, timing looks a little bit delayed here compared to the other models. A little bit later. Definitely southwesterly flow across the southeast. Nice, almost west-southwesterly flow there, which is a positive in my experience looking at these Dixie Alley setups. Even the main jet streak a little bit more of a southwesterly orientation than the NAM showed. But then you get your jet streak to move in by about between 18 and 0Z, and that looks pretty solid. That probably is the best depiction of the three as far as the upper trough goes. Let's look at 850 millibars here. We'll zoom into the southeast. And let's go through Wednesday. Yep, potent low-level jet across the region. Not much change from the other models. 40 to 50 knots across the entire region there out of the southwest. So let's look at the surface flow. Keep in mind these 850s out of the almost due southwest there. Let's look at our moisture and our surface pattern here. And broad warm sector, a little bit farther west, and the Euro looks like it pulls that moisture up quite far north, kind of like the NAM did. So Still some model discrepancy here, and this looks more like it to me. We'll see much more southerly winds in the warm sector than southwesterly winds at the surface in the warm sector, but ample moisture there. Can't see soundings on this, but assuming the winds are out of the south here at the surface and they veered to southwesterly at 850, that would that would be some nice curvature in the low-level hodograph there, per, potentially indicative of a tornado threat. So let's look and see about this EML question. So we'll look at some current soundings here and see if there's an EML already in place and whether or not we would expect it to be advected out to the east. Pretty cool air out here across the source region for the EML. 33 down there at the station in Mexico. El Paso, 32 over 20 this morning. Here's Albuquerque. So the air is cooler. We do see some steep lapse rates there across the region here aloft. And if we go east to Midland, let's go to Del Rio. We see some semblance of that here at Del Rio. Some steep lapse rates aloft right in there. Brownsville, we definitely see Corpus Christi, what appears to be an EML. Brownsville should be much of the same. Yeah, that's a very stout elevated mixed layer there. So I would expect this to get there's this remnant sort of EML to get advected out east. There doesn't seem to be much, though, in the source region, as what we typically like to see for an EML. It is earlier in the season, so cooler air out here in general. That's going to be my major question mark with this setup as far as discrete tornadic supercells go. Are we going to have capping that's going to hold back storms in the warm sector early on so we don't just get a mess of storms all going up at once? If we can get that EML in place, I think there's a good shot that we see a tornado threat, at least for discrete supercells on Wednesday. Here's Shreveport. Very steep layer of lapse rates there. Layer of steep lapse rates there. Could be considered an elevated mixed layer there. So assuming that doesn't change a whole lot over the next couple days, there does seem to be a little bit of a semblance of an EML still residing over these regions, but we'll have to wait and see. Also, so you can see a lot of sort of discrepancy in the models here. We're still 4 days out, 3.5 days out. So we'll have to watch the models closely over the next couple days and see if we can get some more agreement about the position of the warm front, which will, as we said, modulate how far north the severe threat goes. Whether or not we get that EML there, the orientation of the surface low and the surface winds. How can we get some more agreement on the sort of the hodograph shape, the wind profile? But just from the initial look at things, there's going to be a very broad warm sector with very moist air and a potent trough impinging on the region with a pretty strong low-level jet throughout the day. So usually that means severe weather of some form. Still, details need to be worked out about whether or not that's going to be a squall line with more of a damaging wind, an embedded tornado threat, or more of a discrete supercell threat with potential for significant tornadoes. Right now, is just looking at the wind profiles, not seeing much of maybe a significant tornado threat. Those photographs we looked at were indicative of maybe a tornado threat. Don't know if we'll see a significant tornado threat. Again, that's going to depend on mode and if we can work those kinks out with the wind profile. But does look like there's going to be a severe weather event on Wednesday. We'll just have to wait and see how things play out to see what kind of severe weather event we're going to get. So that's all I've got for now. Looking to be back over the next couple days for another video as we get some more model agreement and the data starts to come in. We see how things play out over the next couple days. So thanks for watching, and we will see you next time.